Today we understand binary to hexadecimal conversion. Okay, we know binary means we have two digits, that is two numbers, 0 or 1. Base is 2, we know that. And in hexadecimal we know we have 6 hex plus 10, total 16. That's why we are writing base as a 16. What are 6 numbers? There are 8 to f. We know a equal to 10 and so on, f equal to 15, right? B, C, D is there, okay? And 0 to 9 anyhow we have. So total 16 digits or 16 numbers we have in a hexadecimal. Okay, so this conversion from binary to hexadecimal, we have two methods. Okay, let me go with the first method. Method 1. For example, I am taking a value here, that is 1 0 1 1 0 1 0 1 0 1, right? This is a binary number. We have to convert this number to a hexadecimal number. The base is 16. Okay, so in this method we making as a group of 4 digits or 4 numbers from right side, like this. So from right side 4 digits, make it as a group. The group will be 0 1 0 1. Next group of 4 numbers, that is 0 1 1. Next group is 1 0 1 1. So we created a group of 4 digits. Okay, at the top of this each group you write down 1 2 4 8, 1 2 4 8, 1 2 4 8. Okay, why we are writing this one, I will explain you here, and why we are taking this 1 2 4 8, right? Anyhow, we are converting binary numbers to hexadecimal, so binary we are considering here. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. 2 to the power of 1 we know it is a 1, and 2 to the power of 1 is 2, and this is the 4, 2 to the power of 4, and 2 to the power of 3 8. Okay, 8. So add these numbers, what you get? 9 8 plus 4 9 10 12 14 15. So 15 we are getting, that is in hexadecimal f value, that is maximum number. Okay, so that's why we are making group of 4 numbers here, and we are writing that values 8 4 2 4 at the top of each group. So next thing what we have to do, we have to multiply with top values, this with the top value. 1 1 is 1, 0 2 is it's 0, 4 1 is 4, 8 0 is 0. So this is the one value. Next this group, 1 1 is 1, 2 1 is 2, 4 1 is 4. Okay, 8 0 is 0. Next this one, this group I am writing here at the bottom. Okay, 1 1 is 1 plus 2 1 is 2, 4 0 is 0, 8 1 is it's 8. Okay, so now what we get from this group, 4 plus 1 it's a 5. From this group 4 plus 2 6 plus 1 7 we are getting. From this group 8 plus 10 8 plus 2 10 and plus 1 11. So 11 7 5 we are getting as a hexadecimal. But what about 11? 11 is nothing but a b. How can I say that? A equal to 10 we know, b equal to 11, that's why I am writing b, okay, instead of 11. 7 anyhow we have, and 5. This is the hexadecimal number after converting from binary. Okay, we have taken this one as a binary number and we converted it into hexadecimal. This is the method 1. Okay, now we will go with the method 2. Okay, method 2. In method 2 we have to create a table. Okay, right, that equivalent gives a equivalent value to binary and hexadecimal. First we will go with the binary and we write down hexadecimal. Okay, we know hexadecimal numbers I am writing here. First one is 0, we have 1 2 3 4 5 6 7 and 8. Okay, again I am writing here binary and hexadecimal. Okay, next number we have 9. The 9 after we have A, that is nothing but 10. B, it's nothing but 11. C, 12. D, 13. E, 14. 15, F we say. Okay, now we write relevant equivalent binary value to this. Anyhow, 0 is 0. Next highest value in binary 1. Next highest value, that is 1 0. Next highest 1 1. Next highest 1 0 0. Next highest 1 0 1. Next highest 1 1 1 0, right. Next highest 311. Okay, next highest 1 300, right guys. Okay, next highest 1 0 1. Next highest 1 0 1 0. Next highest 1 0 1 1. Next highest 1 1 0 0. Next highest 1 1 0 1. Next highest 1 1 1 0. Last one 4 ones. So these are the equivalent values to binary equivalent values to hexadecimal. So we want 4-digit number now, so that's why I am adding zeros left side. Okay, here 3 zeros I am adding. Okay, we know any number of zeros we add left side, it doesn't change the value, right? So here also I am adding 3 zeros, here 2 zeros. To make it as a 4-digit number I am adding zeros here. Okay, now it become 4 digits. This one also, this one also, this one also. So now we get each binary in a 4-digit form, right? So like this. Let me take an example here. I am taking a binary number. Suppose 1 1 0 1 1 1 0 1. Okay, right. So this number we have, right. To make it as a group of 4-digit number, so this one is the first number, right. Next 4-digit, this one, that is okay. Next we have 3 only. We additionally we can add 0 at left side, it doesn't change the value, so I am doing that one 0. Okay, now we separated with the 4-digit number group 3. Okay, let me go with the first one. 1 1 0 1. 1 1 0 1 means it's a 13. 13 means D. Instead of this number, simply we write D. Next group 1 0. 1 0 is nothing but it's E. Okay. Next 0 1 1 0. 0 1 1 0 is nothing but 6. So what we get? 6 E D. It is nothing but a hexadecimal number. In this method, by using this table, we easily convert from binary to a hexadecimal number. So this is the method 2. Thank you for today.